are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
Hello, everybody. It's a pleasure to be here to talk about, as Zach mentioned, talk about how it's possible to bring some of the emerging technologies and concepts such as digital twin and artificial intelligence to civil infrastructure asset management to really bring the asset management for civil infrastructure to the way that it should be in the 21st century. So I'm going to go ahead and share my screen. And for this conversation that we are having and the session that we are having today, the way that we have designed the presentation is first I'm going to start talking about our company and the technology and all that good stuff. And at the end of it, we're going to have time for question and answer. So please engage. And both me and my co-founder Edgar is in the room. So we're going to make sure to go through the questions and answer all of them. If there's some more left, we can continue the conversation, of course, in the Shadow Summit Slack channel. So with that being said, I would start the conversation and the presentation for today's session. We can all agree that civil infrastructure is the foundation of our society to operate and thrive. Yet infrastructure around the globe is in terrible conditions. US regulations requires biannual assessment of all the 600,000 bridges that we have in the country. Still, 56,000 of those bridges are structurally deficient, with the most famous one being our beloved Brooklyn Bridge here in New York City. On a daily basis, more than 200 million people cross bridges at risk. And shockingly, there's a bridge failure once every 3 days in the country. What you see on this slide is one of these famous failures in Minneapolis, which killed 13 people, injured 145, and it was a $100 million settlement. On top of that, state had to pay $240 million to just replace the bridge. So let's take a closer look at why we essentially end up in this mess as a society and as an industry. So the way that the current methods of inspection, assessment, and management of infrastructure is precarious and outdated. We have to send inspectors out in the field, and they're using bucket trucks, rope access, ladders to get access to different parts of the asset, and they're using naked eyes to detect teeny tiny damages on miles and miles of infrastructure. And after doing all of that, now they have to go back in the office, go through their field notes, go through the decades of the assessment reports, and see really if the asset is deteriorating or not. What you're seeing in this slide is, and as I mentioned, inspectors be it out in the field in the first column, and in the second one in the middle, what you're seeing is an actual bridge report. And it's not just for the bridges. This is the same concept that we have for building facades and other asset classes, that now the engineer come back in the office and start to put together a report, which is not more than where's the location of that asset, a couple of photos of it. And then what you see on the bottom in the middle is CAD drawings. So engineer has to go through AutoCAD, draw the elevation, and also draw the damages that they found out in the field. And they took notes on a piece of paper, and now they have to digitize all of that in AutoCAD in a manual, which is a manual process and a tedious process as well. And at the end of the day, when it comes down to how we do this data management on top of all of this, it's a very much old school bunch of Excel sheets, which now it's hosted in the cloud. So it's very much the data that goes in is those subjective and inconsistent information. And at the end of the day, those poor information is what really feeds the maintenance plans. And as a result of it, we lose trillions of dollars of infrastructure budget on an annual basis. At Aren, what we do is we are bringing our patented technology to tackle all these problems. We are building a business-to-business software as a service infrastructure management platform to assess and manage infrastructure using a unique combination of machine learning, computer vision, and civil engineering. In a nutshell, we are building a digital health record of the asset. our goal is to reduce the risk of failure while extend the service life of these important assets. So let me walk you through how our product actually works. First, our software aggregates data that the client provides from different sensors and drones and laser scanners from an asset such as this one, which is a 60-meter long bridge. What you're seeing here is one of our projects in the Netherlands. Second, our platform can automatically build a high-resolution 3D digital twin of the asset with unprecedented accuracy, capable of capturing millimetric details such as this crack that you see here. On this slide, what you're seeing are the screenshots of the 3D model. So let me emphasize, these are not 2D photos. These are actual, accurate 3D twin of the asset. Third, by using artificial intelligence, our platform can automatically detect and quantifies severity of different damages from corrosions to cracks. And of course, this is something that we do in 3D and in the context of the assets. And the way that we build our technology is that we can apply it to different materials and to different assets, of course. And of course, there's more. We have the capability to quantify changes in time to see how a damage evolves in order to be able to find and calculate the rate of deterioration to predict future structural changes. In other words, we are providing a historical timeline of the condition of the asset. And lastly, actionable insights. So our SaaS platform can automatically put together a data-driven maintenance and capital allocation plans in order to reduce the risk of failure while optimize the spending across the asset portfolio. In our case, data collection is as easy as taking photos with your iPhone. Everybody can do it, which makes our solution scalable. Now, instead of spending weeks to assess the health of the asset, now the engineers can do it within a matter of hours. Now, instead of having access to the asset once every year while you're at the site, now the engineer can get back to it virtually as many times as it's needed from wherever they are around the globe. Our product is sticky because it is mandatory to conduct structural integrity assessment within decades of the service life of the asset. And that is true throughout the globe. And on top of all of that, our technology is hard to replicate, and it's backed by 10 years of R&D and 3 patents that we have. So our clients have used our technology to assess the health of different asset classes across the globe, from bridges in Alaska to dams in Maryland to building facades in New Jersey. In all of these cases, by using our technology, they were able to reduce the time of assessments by up to 50%, saving them tens of thousands of dollars, but more importantly, saving them millions of dollars from costly litigations and poorly spent budgets. So let me show you the technology in action in terms of assessment of different asset classes. So what you're seeing in this slide is one of our projects in New York City on Roosevelt Island. And this is an old chapel built in 1888. As you may all know, New York City is a no-fly zone. So we couldn't use drones, and our client couldn't. So what we ended up doing was using a off-the-shelf point-to-shoot Nikon camera, 16 megapixel. We went around the object, took almost 250 photos in a matter of 30 minutes, came back, put together in an automatic fashion, put together this 3D model with unprecedented accuracy that you can see all the nitty-gritty details, including that missing brick on the asset. Especially in the post-COVID world, having this digital replica by itself has a huge value. But as mentioned before, the most important thing is that actionable insight. So what you're seeing here is the heat map of all the damages that we found on the building facade, mapped into 3D, showing the different level of severity of the damage on the facade. So in those 2 examples that I showed you, the red ones are showing no damage, and you go all the way to blue color showing the maximum amount of damage, which in this case, it was that missing brick. And of course, we quantify all of those changes. Another asset class, this is a bridge pier in Northeast, and this was a roughly, we can say, a newly built bridge that, it was a $500 million project to build the bridge. And within the bridge inspection community, like one of the key things that the inspector has to do is crack mapping, basically documenting all the cracks on the asset, writing it on a piece of note, and also go back and create that CAD model. So in our case, with the client wind up collecting 400 photos with a drone off the shelf. We created that highly detailed 3D model that you saw earlier. All those purplish colors are showing the cracks that we were able to detect in 3D in the context of the asset, of course. And now what you're seeing is by hiding the pier, you can see all the patterns of the crack throughout the pier, which is important from the structural engineering point of view, the pattern of the cracks. And on top of that, what is important is we know the dimensions of each and every of those cracks, which, if I'm not wrong, on this asset, on this part of the asset, we had more than 1,000 cracks. And now we have the length of them, the width of them, and of course, the locations of them in 3D. So one of the key things that you have to keep in mind is what has happened when an inspector is in the field. I used to do inspections, and our scientific director also have very much good experience in doing inspections out in the field. So what happens is you're out in the field and you basically have to eye roll and look for damages, different parts of the asset. And of course, some parts of the asset, you go to them first because they're more critical versus the other part of the asset. But at the end of the day, you start 7 a.m. in the morning, and by noon or a little bit after that, you're pretty tired. It's going to be hard to find damages, or it's going to be like you're going to miss a lot. According to some of the studies that done by Federal Highway Administration and Transportation Research Board, TRB, what we have is this inconsistency between the bridge reports, for example, that for the bridge rating, which goes from 0 to 9, we usually have plus or minus 2 in terms of standard deviation of the differences between the ratings that maybe a experienced engineer did versus another one who's a newbie, for example. And according to some of those studies, when we do these bridge inspections or other kind of asset classes, we're only able to document between 40 to 50% of all the damages that we have actually on the asset. Again, because it's a very manual and tedious thing to do. So in our case, the key thing is by using our technology and applying that, we are moving towards a consistent and objective assessment. As an example, here what you're seeing is a photo from underneath of the bridge that I showed you earlier, which was in Netherlands. So in the zoom in portion, which is basically the red box that I put in, and this is the zoom into that part. If you pay enough attention, right in the middle, you should be able to see a teeny tiny crack, a hairline crack, which essentially, if you're out in the field, there's a very good chance that you're going to miss that, because again, it's teeny tiny. But when that data came into our platform, that one single photo, for example, you're able to detect that crack, or I should say, you're able to detect cracks or any kind of damage at that level. And that's what you're seeing here. That really helps us to move to that, having more data, more thorough analysis, and now having this consistency between these reports that you're able to generate using the new technology and on top of the data that is provided by the client. And of course, not all the damages are cracks. We have different kind of damages that happens in different materials. And the way that we work and tailor our technologies, we are able to detect those damages in different materials. And as an example here, what you're seeing is, having a combination of efflorescence and also cracks happen on this piece of asset. And, it's important to remember that all of these damage detections and assessments happens in 3D. Everything is quantified. So for example, that piece of the asset, we know exactly what is the areas of efflorescence and what are the damages that, what are the classes of different damages that we have on the asset and what's the severity of them. And all of that now, instead of having in PDF reports or in thousands of photos, now everything is in one single 3D model of the asset. So when it comes down to our beachhead markets and the markets that we are going after, in the US, we are focused on bridges and building facades, which they account for $18 billion opportunity for Aren. It's worth emphasizing that our overall goal is to go after the $3 trillion that we spend on infrastructure on an annual basis. We have started in early 2019, and currently we have a sales pipeline of $1.5 million across North America, Europe, and East Asia. And we are on track to bring thousands of assets to our platform in the near future. Currently, we are working with major global asset owners and engineering firms, including the Dutch Ministry of Infrastructure, who owns thousands of assets in the Netherlands, and of course, with a major global industrial firm who has access to 10% of all the bridges globally. Our team has PhDs in computer vision, machine learning, and civil engineering, and has worked at top-tier consulting engineering and management consulting firms. We are proud to have Cornell Tech Jacobs Institute, Metaprop, and National Science Foundation as our investors and advisors. We are pushing the boundaries to improve the safety and resiliency of infrastructure around the globe. I invite all of you to join us in our mission. We are Aren, and thank you so much.
Well, thank you so much, Ali. What an incredible presentation. And by the way, I didn't mention it in the beginning, but everybody should know that Aren is absolutely one of our favorite incubator companies here at Shadow in our Shadow Labs program. We've had the pleasure and the privilege to get to know Ali and Ali's team, and we really are such big fans of the work that you're doing. So thank you, and thank you for this presentation. We do have a few extra minutes.
Thank you for the opportunity.
Absolutely, absolutely. We have our first question here. Okay, great. So this person says, I worked with a company that uses IoT sensors to anticipate bridge issues, especially ones that are not visible. Can your platform include multiple data perspectives?
So that's a very good question. And that's a very important thing that we are working on in terms of being able to not only use the visual data sets, as I mentioned, images, videos, and 3D laser scan data and all of that good stuff, but also be able to use other non-destructive evaluation tests that happens on the assets, especially with the bridges, impact echo, ground penetrating radar, all those kind of cool gadgets. And one of the key things that we're working is, and we have the capability in terms of fusing all of that information, running our analysis on top of that to get a good picture, or maybe I should say a holistic view of what's actually happened on the surface of the asset, and also at the subsurface level of the asset.
Excellent. Okay, let's see. Do we have any other questions from the audience right now? We'll give it another minute or so. While we're waiting, Ali, are you in New York City right now, or?
Me right now, I'm actually down in Washington D.C.
Oh, okay, got it. So after Cornell Tech, you moved out.
Yep.
I got it. Oh, okay. We have another question. What digital twins platform do you see emerging? What digital twins?
I mean, platforms and digital twin. So digital twin by itself, I know that it is not a new concept. Yeah, it's been around in aerospace, and NASA started it a couple of years ago. It's a little bit new thing within the construction or civil engineering industry. On top of my head, unfortunately, though, I cannot name the platforms working on digital twin, which really pops out, and they're impressive. Sorry if I miss some names there, but I cannot think of something.
Absolutely. Okay. Next question. Oh, the same person asks about Bentley.
What are Bentley?
I guess my assumption is that Bentley must be one of these digital twin platforms, and he wants to know more, but I'm not sure. Okay. Next question. Is your technology applicable during the construction phase of the bridge as well?
So the focus that we have is very much on the operation and maintenance side of things. So while within the construction that it's happening, if you're looking at it from construction progress monitoring per se, that's not our focus. But one of the things that we're working on with some of our clients is basically the QA QC that it happens right after the construction is done and before you hand it to the asset owner. Those firms, construction companies has to run that QA QC, and we are helping them on that front in terms of building a 3D model, a digital twin, if you will, of the asset with all the damages. So that starts to be the reference for the future that, hey, this is the way that things are changing. So that is going to be our focus, operation and maintenance, or maybe, if we want to get closer to the construction itself, it's going to be the Q and QC right after construction.
Got it. Okay. Oh, wow. The questions are really flying now. Can your tech capture rare defects without many samples to train?
So one of the good, or one of the beauties of our technology is some of the pieces of technology is very much rooted in machine learning. So it has to have the training data and the sample data and all that kind of good stuff. But one of the key things also about our technology is we are working with the 3D model itself, and we are using computational geometry, if you will, which is not machine learning. We take the 3D model, we run our analysis, we find different irregularities that happens on the surface of the asset, and we put like a red flag on them and say like, hey, here's something that you have to take a look because it is abnormal. And that for those kind of things, again, it's not machine learning, it's pure computer vision and computation geometry.
Got it. Okay, I think that's all the questions we have right now. I would encourage everybody to, if you have more questions, absolutely, you should post them in the Slack channel for Summit. You could reach Ali and Edgar and the rest of the team that way, whether it's later today or this week. And wow, again, many, many thanks to you. This was an incredible presentation, and looking forward to catching up with you soon.
Absolutely, Zach. Thank you so much again. You have a wonderful one.
Take care.
And thanks to all the audience. Bye-bye.